This is Unit 1, Lesson 3, Reducing Radicals. Okay, we're going to start by square roots and then take a look at cube roots and other things as well. So remember, a square root, this is a symbol that we use for square root. And a square root, when we're taking square root of a number, we are finding out what two numbers, when you multiply them together, give you this number underneath. So 64 is what we call a perfect square. And if you were to type this into your calculator, you would get 8 as your answer. What we're going to be exploring in this unit is what happens when that number is not a perfect square. Okay, so if you were to type in the square root of 32 into your calculator, you are going to get a decimal. Now there's nothing wrong with the decimal, but what we're going to learn is how to write this answer in what we call simplest radical form. Okay, so we are not going to be giving a decimal answer. So here are steps that we are going to use. All right, step number 1 is find the prime factorization of the number inside the radical. Okay, so what we're going to be doing is we're going to be dividing it down into all of its prime numbers. Remember, prime numbers are any number that can be divided by just 2 in itself. So I've got 2, 3, 5, 7, 11, and we can go higher. 2, 3, and 5 will be the most common ones that we'll see in this, but of course, any prime numbers we can work with. All right, after we do that, we're going to circle pairs, two numbers of a kind. If I circled a pair, one of them goes to the outside, and any remaining number stays under the radical. Let's take a look at an example because it's kind of much easier to see what's going on when we're working through a problem. So let's start with this first example, the square root of 12. So once again, we want to start by finding prime factorization. So we're going to start by dividing. Always start by dividing by 2, okay? If you get into a pattern, it's easy to remember where to start. So if I do 12 divided by 2, I get 2 and 6, okay? Now, 2 is prime, so I'm going to stop there. I don't need to do anything else with the 2. 6 is not prime. I can divide that down into 2 and 3. Okay, and once again, this 2 right here is prime, and 3 is prime. So I'm good to go. All the numbers at the bottom of my, you can call them trees, are prime. So something I like to do to help me organize my thoughts is any number that has branches off of it, like this 6, I cross it off. And I cross the 12 off so that I don't try to use it again, okay? So now what we want to do is we want to circle any numbers that are 2 of a kind. So I see I have a pair of 2's here. So circle them. Doesn't matter if they're on the same tree branch. Okay, that's what I'm calling these little numbers, branches off the 6 and the 12. Doesn't matter if they're on the same one, doesn't matter if they're on opposite sides of the problem, just circle any 2 of a kind. And as soon as you do that, cross one of them off. Okay, now I see this, I have this 3 left over. There isn't another 3, so that one just stays by itself. Okay, so any number that's circled is going to go to the outside of my radical. If I had more than one number, and we will see it in a problem later, but if I had more than one number circled, I would multiply them. Here I only have the 2, so that 2 is going right here. This 3, any number that's not circled, stays underneath my radical. All right, so my final answer is 2 square root of 3. 2 square root of 3. Okay, because remember, when I broke this 12 down, I had 2, 2, and 3. If I were to multiply those together, 2 times 2 times 3, that gives me the 12. Okay, so I'm just changing the numbers that I'm working with. They're all equivalent to each other. All right, let's take a look at my next example, the square root of 52. So once again, I'm going to start by dividing by 2. If I divide something by 2 and it doesn't give me a whole number, then try your next prime number, 3. All right, and 5, and keep going up. This does, I get 2 and 26. Okay, 2 is prime, so that's done. My next example, when I divide it down, I'm going to get 2 and 13. 2 is prime, 2 is prime, and 13 is prime. So I'm all set with that for right now. I'm going to cross off those numbers. Okay, because the 52 was broken down, and so is the 26. So now I want to circle any pairs I see. So I see a pair of 2's, and as soon as you circle it, cross one of the 2's out. Doesn't matter which one. All right, but I notice I only have 113, so I can't circle that. Okay, so when I go to write my final answer, since the 2 was circled, that's going to go to the outside. The 13 is not, so that stays underneath. And my final answer is 2 square root of 13. All right, so now we see in these two problems, I have a number already on the outside. That's okay. We can work with that, no problem. All right, so let's start by breaking down this 100, okay? So I'm going to break it down into 2 and 50. 2 is prime, so it stops there. The 50 can go into 2 and 25. 2 is prime. 25 goes into 5 and 5. Okay, and that's my prime factorization right there. 2, 2, 5, and 5. Okay, so let's make pairs. I see a pair of 2's, cross one of them off. I also see a pair of 5's, cross one of them off. All right, so anything in a circle is going to the outside of my radical. So I'm going to just write this right now. And if I have more than one number going out there, because I'm going to take the 2 and the 5, I'm going to do 2 times 5. All right, now, before we talk about underneath, notice this 3 in the original problem was already outside. Since it's already outside, it's going to join these guys on the outside. So really, I'm going to do 3 times 2 times 5. And then I do the square root of what's left that's not circled. Now we'll take a look at our numbers. All of our prime numbers are in a circle. So when there are no numbers that are left over, that means that I'm not going to have anything underneath my radical sign. Okay, so when I write my final answer, I'm going to multiply 3, 2, and 5. 3 times 2 times 5 gives me 30, but I don't write the radical sign. Okay, I don't put this symbol anymore because if there's nothing to write underneath, I don't need it. Now, if you notice when we started the problem, 100 is a perfect square. The square root of that is 10. So if you notice that, you could have just done the 3 times the 10 and gotten the 30 that way. But if not, breaking it down using your prime factors, you would have gotten the same answer. Okay, so once again, recap what happened. A number that started on the outside stays on the outside. If there are no numbers left from your prime factorization that aren't in circles, I get rid of my radical. All right, our next example. Oops, sorry. We're going to break down the 147. Okay, so if I do 147 divided by 2, I don't get a whole number, I get a decimal. So 2 doesn't work. It's not divisible by 2. So try your next prime number. Try 3. I notice I'll get 3 and 49. Okay, 49. 2 does not go into 49. 3 does not go into 49. 5 does not go in, but 7 does. 49 breaks into 7 and 7. Okay, circles, 7's, cross one off. Okay, so going to the outside, I have 7 and 5. So 7 times 5, 35. The only thing left to go underneath is my 3. And that is my final answer. All right, let's take a look at this one together. 23. 2 does not go in. 3 does not go in. 5, 7, 11, 13, etc. 23 itself is a prime number. So if I'm asked to reduce a square root that either has a prime number in it already or a number that won't give me any pairs. For example, if I did the square root of 6, I have 2 and 3. I don't have 2 of a kind. Okay, so what that means is that's already reduced. It's already in its simplest form. So for this problem, the answer would just be the square root of 23. For this problem, it would just be the square root of 6. Okay, so that can happen when you're asked to reduce it, but it already is. All right, the next thing we're going to talk about is reducing what we call cube roots. We are going to follow the same exact steps as square roots, except we're going to make triples. We're looking for 3 numbers that are the same. Okay, 3 numbers that are the same. All right, now a cube root is this little symbol right here. When there's a little 3, okay, it's not a big 3 in front like this, it's a little 3, that's telling you to find a cube root. Okay, 3 of a kind, 3 numbers that multiply together. So look at this first example. We have that little 3 there. So we're going to follow the same steps. We're going to break it down. 2 and 36. 2, 18. 2 and 9. 3, and 3. Okay, and get rid of anything that has numbers broken down so you don't confuse yourself. All right, now, because I have this little 3 in front that's telling me to make 3 of a kind, which I have right here, get rid of 2 of them this time. So whenever you circle numbers, whether you're circling 2 or you're circling 3, only one of them ever remains, okay? Only one ever remains. So I have 3 of a kind right here. Can I do anything with these 3s? No, I don't have 3 of them. And once again, this problem's saying you need to make groups of 3 of a kind. All right, so now we do the same thing. The 2 goes to the outside because it's in the circle. The 3 stays underneath. And please make sure you include that little 3 in your final answer. Very important. All right, the next problem. Same process. I've got 2 and 10,024, 2, 512, 2, 256. I'm going to run out of room. 2 and 128, 2 and 64. I'm going to move over here. 2 and 32, 2 and 16. This one's got a lot of 2s, huh? 2 and 8, 2 and 4, 2 and 2. All right, so let's cross off. Okay. Now, you notice I have a lot of 2s. Make as many groups of 3 as you possibly can. Here's 1. Get rid of 2 of them. Here's a group of 3. Get rid of 2 of them. Oops. Well, this 2. Here's a group of 3. So they don't have to be near each other. I could have done that better with drawing. That's okay. Get rid of 2 of them. And then I've got 2 left over. Okay, so I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 2s to start with. So I should be able to get 3 groups of 3 out of them. Good. Okay, so I've got 1, 2, 3 2s to the outside. So I have a 2 times 2 times 2. And cube root. And I have 2 2s left to stay underneath. So then I multiply. 2 times 2 times 2 is 8. 2 times 2 is 4. So that is my final answer. 8 cube root of 4. All right, 20. Break it down into 2 and 10. Break that down into 2 and 5. Can I make any groups of 3? No. So cube root of 20 is my final answer. It was already simplified. All right, 1080. 2 and 540. 2 and 270. 2 and 135. 3 and 45. 3 and 15. 3 and 5. Now, there's different ways you can get to your answers. So like when you get to 135, if you divide that by 5 and use different work, that's okay. You'll get the same numbers all at the end. All right, so let's cross off things we don't need. 3 of a kind. Here's a group of 3. Here's a group of 3. So going to the outside, I have 2 times 3, which is 6. Staying underneath, I have 5. Actually, you just got to remember numbers that are circled going to the outside, numbers that are not stay on the inside. Okay. Our next example, 2,375. Let's break it down. All right, so I can divide this by 5 and get 475 over here. I can divide that by 5 again and get 95. If I divide that by 5 again, I get 19. All right, now 19's prime, so it's done. I have a group of 3, get rid of 2 of them. So 5's going to the outside, 19's staying underneath. Okay, but notice I already have the 9 out here, so I got to make sure I do 9 times 5 to give me 45. So just be careful when you already have a number outside. All right, divide by 2. I get 729. Divide that by 3. I get 243. Divide by 3 and I get 81. Divide by 3, I get 27. Divide by 3 and I get 9, and 3 and 3. Okay, so I have a group of 3 3s and another group of 3 3s. Okay, so I have 3 times 3 on the outside, which is 9, and the square root of 2 underneath. Okay, so I'll do the same stuff. Once you're comfortable with the pattern, you're just doing the same thing over and over again. Sometimes they're big numbers, sometimes they're not. All right, 2 can't go into it, so I start with 3. Get 3 and 343. 3 and 3 doesn't go into 343, 5 doesn't go in, but 7 does. So I get 7 and 49, which that's 7 and 7. So the more you do this, you'll start to see some numbers like, oh, okay, I already know what that breaks into. You'll get used to it. All right, so 7s make a pair, or I'm sorry, a triplet. 7 times 2, 14 on the outside, cube root of 3. All right, we're going to also introduce variables into this. Okay, so there's a couple different ways you could do it. So I'm going to put a problem up here as we talk through the examples. Excuse me. So you can have the square root of x to the 7th. We'll start with that. So there's 2 different ways you can attack this problem. So method number 1 says list out how many of the variable there are, make pairs, and treat it just like you would simplifying a number. Okay. What that means is if you have x to the 7th, that's telling you have 7 x's. 2, 3, 4, 5, 6, 7. And just like before, I can make pairs and cross one off of each pair. Now notice I'm making pairs because there's no number right here. If there's no number, you're doing 2 of a kind or pairs. If there's a little 3, you're doing 3 of a kind or triples, okay? We're not going to do 3 of a kind with letters. All right, so this tells me I have 1, 2, 3 circles. So I have x to the 3rd goes on the outside, and I have 1 little x left over underneath. So that's my answer. So method number 1 is list them out, make your pairs, count how many there are, and that's going to be the exponent on the outside. And if there's an x left over, it stays underneath. Now, totally can work. However, what if I give you like x to the 52nd? You're not going to want to draw 52 x's. You can, but it's a little more involved. So another way we can do it is to just divide by 2. So if I divide my exponent by 2, the whole number is the exponent that goes on the outside of the variable, or the radical. If there's a remainder of 0.5, then it says one of the letters will stay underneath. So this x to the 7th, when you do 7 divided by 2, you get 3.5. So this is telling me that I have x to the 3rd on the outside. Okay, the whole number is the exponent that goes on the outside of the radical. If there's a 0.5, that's telling me that there is a letter left underneath. Okay, if I did x to the 8th and asked you to reduce that on the square root of x to the 8th, and you do 8 divided by 2, you get 4. So the whole number 4 is what's going on the outside. Since there is no remainder, there's no 0.5, that means there is no x's left underneath the radical. Okay, the only time you're going to have a variable left under the radical, since we're only breaking it down by square roots, is when it's an odd exponent to begin with. Okay, so let's take a look at an example. We can do a number, and we can do some letters together. All right, so when you have both numbers and letters there, you want to kind of separate them. Do the number first, and then we'll worry about the letters, the variables. Okay, we're separating them for right now. So the numbers we can do, break it down into 2 and 10, and 2 and 5. So 2 goes on the outside, the 5 stays underneath. So for our letters, okay, x to the 5th. If I do 5 divided by 2, so I'm looking at my x's, I get 2.5. That tells me x squared goes on the outside, and that's telling me I have 1 left underneath because of the 0.5. For the y's, if I do 4 divided by 2, I get 2. So that tells me y squared on the outside, and since there is no remainder, I don't have any y's left underneath. So now to write my final answer, just combine them together. So I've got 2 x squared y squared on the outside. And the only thing left under my radicals are 5 and an x. So that would be my final answer. All right, bring questions to class, especially if you were absent. Try the practice, and I'm more than happy to help you.